3.4 says calculate the size of LNS. Now to calculate the size of LNS, which is this angle over here, we first need to know a couple of things. We need to know the size of LKO. So LKO would be this angle over here. If we know this angle here, and we also know this angle here due to these vertically opposite angles, we can figure out what the size of L and O will be. Therefore, calculate the size of L and S. Our first order of business is to calculate the gradient of Ln. So the gradient of Ln will be the y of L minus the y of n all over the x of L minus the x of n, like that. And that would give us y of L is 1 minus negative 3 all over the x of L would be minus 4 minus 2. The answer to this will be minus 2. Therefore, LKO, which is this angle over here again, will be equal to the arctan of minus 2. And that will be equal to a value which you have to add 180 degrees to get the obtuse value of that angle. Because if you use arctan of this tangent here, of this gradient, you get the smaller angle here. And in order to combat that, so let me show you what that would look like. Let's refresh that. So we want shift tan of minus 2, and we see we get minus 63, but looking at it, we know that's not the inclination angle. So we need to add 180 degrees to it. And that gives us 116.56. 116.56. So let's say plus 180. That will be equal to 116.565 degrees. Then that's LKO. Then LNS has to be equal to 116.565 minus the angle that we calculated previously, which is 53.13. Why? Because this is exterior angle. Often, so we know that this angle should be equal to this plus that. Therefore, to get this angle here, we need to subtract this other one from the outside one. So doing this gives us a value of 63.44 degrees. That is our value for LNS.